Hello everyone. Today we are going to be going through how to sketch some subsets of the complex plane. So let's begin by first explaining this using just some basic algebra. Let's use the modulus of z minus 1 equals 2 as our first example. Okay, so we do know that z over here is representative of a complex number. Now we are trying to convert this into a Cartesian equation to make it easier for us to graph. So if we are to convert this into a Cartesian equation, then we can represent this potential complex number z in the form of x plus yi. X plus yi. So if we were to rewrite this equation, we could write it as the modulus of x plus yi, which is representative of our z, minus 1 equals 2. Now we know that 1 is a real number and x is also representative of our real number part of this complex number. So what we can do is we can group these together. So we can write this as the modulus of x minus 1 plus yi. Again, the x minus 1 here being representative of the real part of our complex number, and the y over here being representative of the imaginary part of our complex number. So this equals 2. Now, to find the modulus of a complex number, so this is a bit of revision here, but if we were to find the modulus of a complex number, for example, 2 plus 1i, the method to do this would be to use Pythagoras' theorem. So this would be determined by taking the square root of 2 squared plus 1 squared. Okay, and this would simplify to the square root of 4 plus 1, which is equal to the square root of 5. So what we're going to be doing for this example over here is the exact same thing. We are taking the modulus of this imaginary number. So we are going to be taking the square root of the square of the real part of the number and the square of the imaginary part of the number. So let me demonstrate. We are taking the square root of the real part of the number, so x minus 1 squared, plus the imaginary part of the number y, and we are going to square this as well, and that equals 2. If we square both sides to get rid of the square root, we will end up with an equation of x minus 1 squared plus y squared equals 4. Now we have converted this into a Cartesian equation. This Cartesian equation, you may recall, is for the shape of a circle. So we can already identify that this graph is going to be a circle. It will have a radius. So its radius will be equal to 2, which is the square root of this 4 over here. And its center will be at 1, 0. So if we were to graph this equation on a Argand diagram, we would have to convert our center into a complex number. So the Argand diagram equivalent of 0, 1 would just be 1 plus 0i. So our 1 plus 0i can be located over here. 1 plus 0i. And we know that this circle will have a radius of 2. So let's plot those points now. There. Joining these dots, we get the production of a circle. Oh, let me try that again. Taking note of these points, this point here would be equal to 1 plus 2i. This point over here would be equal to 3 plus 0i. This point over here would be equal to 1 minus 2i. And this point over here would be equal to negative 1 plus 0i. Okay, so this was the first method that you can use to sketch a subset of the complex plane in the form of z minus h equals r. Now, just to develop our understanding in regards to this, let's have a look at this equation with a different perspective. So let's use geometry now to figure out how to sketch this subset of the complex plane. So our equation was z minus 1 equals 2. Now, we know that if we're finding the modulus of 2 points, so let those points be z1 and z2. So if we're finding the modulus between 2 points, we know that we're trying to find the distance between 2 points on the Argand diagram, known as z1 and z2. And we know from this equation that this distance will be equal to 2 units. So the distance is 2 units. Now, we know that our z2 in this equation is represented by the real number 1. So essentially, we are trying to find the distance between a point z and 1. Or we can write this as 1 plus 0i. So the distance between some point z and 1 plus 0i must always equal 2. On our Argand diagram, we know that 1 plus 0i is located here. So this is your 1 plus 0i located here. And we are trying to find points that will always have a distance of 2 from this point. So we know that this point over here would have a distance of 2 from 1 plus 0i. So would this point, and so would this point, and so would this point. Again, this gives us our circle. This allows us to graph our circle. Okay, let's try another example now. Let's try to sketch the subset of the complex plane where z minus 2, the modulus of z minus 2 equals the modulus of z minus 1 plus I, there. Again, using the same logic as before, we know z is representative of a particular complex number. We can represent this using x plus yi. So rewriting this, we get the modulus of x plus yi minus 2 equals the modulus of x plus yi. And I'm going to expand this bracket out. So minus 1 minus I. Okay. Again, we can group the imaginary and the real parts of our complex number. So I'm going to group this x and minus 2, and I will group this x and minus 1, and we will be grouping this y and this imaginary number, minus 1. So we've got the modulus of x minus 2 plus yi equals the modulus of x minus 1 plus y minus 1i. As we discussed before, to find the modulus of a complex number, we will use Pythag. So we will take the square root of the real part of our number, so x minus 2 squared, plus the imaginary part of our number, so y squared. This will equal the square root. Again, we're doing the same thing with the right side of the equation, the real part of the number squared, so x minus 1 squared, plus the imaginary part of the number, y minus 1 squared. Again, we are just going to be using simple algebra to simplify this equation down. So we can square both sides to get rid of the square roots, leaving us with x minus 2 squared plus y squared equals x minus 1 squared plus y minus 1 squared. Now we will have to expand both sides of this equation and then group terms to simplify. So let's quickly do this now. So this first one over here, we'll get x squared minus 4x plus 4 plus y squared. For this part over here, we will get x squared minus 2x plus 1. For this part over here, we will get y squared minus 2y plus 1. We can now begin to group terms and start to simplify. So these two x squares can cancel out, these two y squared can cancel out, and we can begin to group our x terms on one side of the equation and our y terms on the other side of the equation. So over here we've got minus 4x plus 4 plus 2x minus 1 equals minus 2y. simplifying this down, we get negative 2x plus 2 equals negative 2y. Dividing both sides by negative 2, these two cancel out, leaving us with y equals x minus 1 as your equation. So we know that this graph, if we were to graph this on the Argand diagram, would look similar to the equation of y equals x minus 1 on the Cartesian plane. So over here, we will have our line graphed looking something like this, with your y-intercept at 0 minus 1i and your x-intercept at 1 plus 0i. Okay, so again, this was the first method used to understand the shape of this subset of the complex plane. Our second method would be to use our understanding of complex numbers and use our understanding of geometry. Now, we know that this subset represented by the modulus of z minus 2 equals the modulus of z minus 1 plus I. This will include all of the points in the complex plane that are equally distant from the points 2 and 1 plus I. So we know that the distance between 2 and some point on the graph, z, so the distance between 2 and z, the distance between 2 plus 0i and some point z will be the same as the distance between 1 plus I and some point z. If we were to plot these 2 points, so these 2 points on the Argand diagram, so let's do that now. Okay, so we'll plot 2 plus 0i over here, 2 plus 0i, and 1 plus I over here. That's 1 plus I. Okay, now that we've plotted these 2 points on the diagram, we have to determine what point z will give us the exact same distance from it to 1 plus I and from it to 2 plus 0i. And intuitively, you should realize that the point where it will be equally distant to both these points would be in the middle of these 2 points. So if we were to draw a line joining these 2 points, we know that the middle of this line would be where the distance from z to 1 plus I and the distance from z to 2 plus 0i would be the same. However, not only is just this point equally distant from these 2 points, but you can expect that anything out in the periphery that results in the production of this isosceles triangle would also result in this. So the point could be up here, the point could be down here, and it could extend on and on and on. So if I were to clean this up a little bit, we have a rough idea that our graph will be a straight line, or this subset of the complex plane will be a straight line passing through or perpendicular to the line connecting 1 plus I and 2 plus 0i. So connecting this point and this point. So a subset of the complex plane given in this form would tell us that this equation or this subset of the complex plane will be perpendicular to the line crossing or joining 2 plus 0i and 1 plus I. So again, let's go through this once more. That the equation of this subset of the complex plane, so this line over here, would be a line that is perpendicular to the line connecting 1 plus I and 2 plus 0i. Okay, hopefully this gave you a bit of an overview on how to sketch some subsets of the complex plane. whether they're given in the form of a circle or a linear equation. As always, let me know if you have any questions. Otherwise, I will see you next time.